Very good. So good afternoon to all. It is with a great pleasure that I welcome you here to the third edition of the Sustainability Lunch Talks, this time dedicated to the environmental impacts of our mobility and travel patterns. Before continuing, I would like to remind you that this WebEx event is recorded and will be made available in the coming days on the Sustainability intranet pages. So I am Laurent Bétry, I am the Sustainability Officer at the university, and I'm in charge of integrating sustainability into the operations and functioning of the university. For this, I coordinate reflections and actions to develop specific responses at the university to the challenges of ecological transition. One of the facets of my actions involves raising awareness in the university community of the various themes of sustainability. This is for this reason that with members of the Sustainability Coordination and Expertise Group at the university, professors, researchers, administrative staff, and members of the delegations, we have launched this series of discussion. So this series, for everyone, committed or not, its main objective is to restore the facts in the mass of information that is about sustainability. This is why we invite recognized researchers to inform us in a short and interactive format on the contributions of science to the questions we wish to address. Today, during this European Mobility Week, we propose to address the environmental impacts of our travel patterns. Our societies have been revolutionized by the acceleration of our travel, and our economic system is based on mobility of workers and the intense global exchange of goods. Even our leisure activities through tourism are also based on more or less distance trips. And our great mobility at the time we are fighting climate change is being heavily scrutinized and called into question, announcing major changes in the way we think about travel. So to talk about it, we have Dr. Elorri Igos and Dr. Thomas Gibon, both R&T associates at Luxembourg Institute of Science and Technology. And this webinar is co-hosted and moderated by Professor Francesco Vitti from the university, who heads the Transportation Engineering Lab, MobiLab, in the Faculty of Science, Technology and Medicine, and teaches on a wide range of mobility-related topics. As a recognized specialist at the university, he has, among other things, set up the car-sharing service that facilitates travel between our campuses on a daily basis. So I'm done with the introduction, and Francesco, the floor is now yours.
Thank you very much, Laurent, for the kind introduction, and thank you everyone for joining this sustainability talk. I see a lot of people have joined in, so I'm hoping to engage everyone into a nice discussion on a topic that I would say everybody feels very expert on, because we all move and we all know what are the reasons why we are moving, and why mobility is also an opportunity, but also an issue in terms of sustainability. So before introducing the speakers and giving them the floor, just a little bit of an introduction to put everybody into the perspective. So what is mobility? Why do we move? Essentially, mobility is not an activity per se. We don't do it because we like to travel, we like to take a car and move from A to B, but we usually do it because we have a purpose at destination, bringing ourselves to work, or move some goods, or transport some passengers to their own activity. And in that sense, we have been doing a lot of effort since the prehistorical ages to invent solutions for mobility and create new transportation systems that could allow us to go faster, more comfortably to our destinations, but also we are developing more and more greener services in order to reduce the impact of our mobility. And to put again into the perspective of Luxembourg, just some statistics that you may know, but are always impressive to read. Well, first of all, Luxembourg, despite being a small city and a small country, it is within the top 100 in terms of traffic congestion. And this is also due to the fact that we have a large, oops, we've just lost, sorry, I will. PowerPoint has crashed. One second. Okay. Voilà. Can you still see the presentation? Yeah, okay. So this is also due to the fact that we have a large amount of people that don't live in our country and they are commuting long distances to travel to their jobs. This makes it also hard to organize transportation services that are efficient enough and flexible enough and compete with the car mode. And that's also one of the reasons why we are number one in Europe in terms of car ownership. And we also experience one of the largest shares of car trips as compared to the other alternatives of transport. So every year, citizens in Luxembourg experience more than 30 hours lost in traffic jams. And even for Esch, our neighborhood, this is even higher, 40 hours. So every 30 minutes drive, we lose 15 minutes in traffic jams. And this will become worse and worse in the future since our population is growing of 1.5% every year, and we will reach about 1 million people in 2050. So, but why do we bother about this? It's because mobility incurs to everybody some cost. And this is due to the limited space that we are allowing to cars to move, but it's also due to long waiting time, crowding in our transportation systems, which transportation generates a lot of externalities, pollution, resource consumptions, and generally stress for people and delays at work and many other issues. Now, how much does mobility cost to everybody? Well, we are also number one in Europe in terms of how much money we spend on mobility. Nearly 20% of our household income is spent on mobility. And as you can see from these statistics, the largest part of this, and these are statistics before we had free public transport in Luxembourg, so this is from 2017, shows that already in 2017, the largest amount of money spent was on acquiring cars and to use cars. Now, we will talk about carbonization, decarbonization, footprints. And the main talk today will be about calculating the footprint for mobility. So we also are number one in this respect, but this is also, again, not a good news. We are number one in terms of global footprint index. And that's also because of the presence of the cross borders, as well as our mobility patterns, the long distances that we are traveling, which creates this large difference with respect to neighboring countries or other countries in the EU. Now, talking about sustainability and why mobility is often unsustainable is because our choices of using the car creates some cost to the society. If you are walking, then the amount of infrastructure needed for walking is relatively small. Whereas if you are using the car, the resources and infrastructure needed and all the cost aside of it, health issues, for example, are nearly 10 times the amount of money that every person is spending on its own mobility. And we usually don't really perceive this type of cost when we are making a decision whether to take a car, take a plane, or other less sustainable modes of transport. So the future will be to try and come up with more sustainable development solutions. And of course, you may have seen already this picture many times that shows that by using public transport or using active modes of transport, we may use much more efficiently our space. And then digitalization will probably help at doing it. But digitalization needs to be also looked at with a sustainable eye. Because if we start replacing our, let's say, traditional cars with electric cars or autonomous vehicles, this will probably not fully solve our problem. So we have to all think and cooperate all together to have more sustainable and more concernful decisions of how we move in order to reduce our carbon footprints. So having said that, let's make mobility more sustainable. And let's now give the floor to Thomas Gibon for starting the presentation on their side. So the floor is yours.
Hello, everyone. Can we hear me? Should be working. I will share my screen now. Okay. Can we get a confirmation that you can see the presentation? Excellent. Okay. Well, hello, everyone, and thank you for the invitation. My name is Thomas Gibon. I'm a researcher at the Luxembourg Institute of Science and Technology. I focus on carbon footprinting, environmental impact assessment, and a bit on mobility. And with me is my colleague Elorri Igos that will take on the second part of the presentation. Today we'll take half an hour to talk about carbon footprinting first, to try to explain what is the exercise of accounting for carbon through our everyday actions, so what carbon emissions we are responsible of. We will see that mobility is a major part of it, especially in Luxembourg, for some reasons that Francesco just gave before. And then we will try to explore a bit, go into the details and understand how we can actually be better and emit less carbon through better mobility measures. Before we start, just be aware that there's going to be 2 questions during the presentation. Don't answer them now, but you can access them through menti.com with the following code that is also in the chat. So after I'm done with this slide, you can still find the code in the chat, but you will have to wait for Elorri to ask you the question before answering, please. Okay. So first, I think most of you are aware about what a carbon footprint is, but I will go through it starting from scratch again, make sure everyone's on the same page. I would like to start with this graph, which is actually a graph showing on one side the total amount of CO2 we have emitted since pre-industrial times, which is roughly the mid-1800s, 1880s, and the temperature change relative to that time. Today, we have emitted about 2.2 thousand billion tons of CO2 in the atmosphere, which are still there from, they were trapped underground for millions of years. So it's quite a big imbalance in the amount of carbon we have in the air, which has led to the increase of temperature of about 1.3, 1.4 degrees today, which we start feeling the effects of. If we do nothing, by the end of the century, we would overshoot that, and we will go way beyond 4 degrees, which is considered as catastrophic by the IPCC, the Intergovernmental Panel on Climate Change, since we will have systematic episodes of heat waves, droughts, floodings, sea level rise as well. A lot of threat for biodiversity, but also think of food supply issues and possibly migrations around the globe. So a lot of instabilities we don't want to have. What we could do is to try apply efforts, so decarbonization measures mostly, which could lead us to about 3 degrees if we continue with our current system. I think the last number for where we're going right now is 2.7 degrees. But you may be aware that there's a target of 2 degrees actually called, it's termed well below 2 degrees, which would only allow us to emit 900. The graph is already a year old, so I would say 850 billion tons of CO2 that we are left to emit forever. So this is our carbon budget. to stay and remain under the 2-degree target that has been set in 2015 in Paris, now called the Paris Agreement. I hope this graph shows the tremendous amount of efforts we have to do all together around the globe. So from our scale in Luxembourg to everyone globally to actually reduce and limit this global warming. So now I've been talking about CO2 a lot. CO2 is actually emitted because mostly of fossil fuel combustion. The winning trio, or the infamous trio, would be oil, gas, and coal. They all have their purposes. Oil is mostly used for transportation. Coal is mostly used for electricity. Gas is used a bit for electricity and industrial heat. There's a bit of process emissions coming from cement factory, for example, and change of land use. This is mostly deforestation. There are other gases than CO2, namely, fluorinated gases that you find in refrigeration, the nitrogen monoxide you find in agriculture, and CH4, methane, that you find also a lot in agriculture. So for mobility, the main concern is really CO2 at this point. Of course, we as individuals don't consume or don't emit directly CO2. We do through burning fuel in our in our cars or using gas at home, but most of it is actually emitted through the combustion of these fossil fuels in other machines that are used for our own purposes. So, for example, power plants, which are then used to move engines and motors, also industrial burners. There's some emissions in agriculture. And the whole game of carbon footprinting is to link these emissions here on the right to a final service that's provided to us as a population. I don't burn coal at home, but somewhat by using electricity, I'm responsible for coal being burnt in some power plant somewhere in Germany. So that's this link that we're trying to make in our everyday job as well, and that's important to have this systemic view of the problem. Okay, so now focusing back to Luxembourg, we have done that job. It's still an ongoing work, but to actually plot, so this time we're not talking about billions of tons, we're talking about tons only of CO2 per inhabitant per year due to transport, to housing, to food, to consumption goods, and to services in Luxembourg. So the total is about 13 tons CO2 equivalent. It's actually a lower end. We're still working on the footprint calculation. But what is clear is that mobility occupies most of the space on this graph. And we will see in the next slides that car is single-handedly the most important contribution to this carbon footprint. So I don't think we have much time to spend on this graph, but I just wanted to show it. We have a target of 2 tons to be carbon neutral in 2050, so we have to move fast. So now we will focus just on the gray part, the mobility part. Our carbon footprint is mostly the product of 2 things. It's our use, how much we use, how much we drive, how much we travel, times how much carbon each kilometer will emit with each mode. So we can plot the same thing as we had earlier, mostly with cars. We travel about 12,000 kilometers per year per inhabitant in Luxembourg, and with a carbon intensity of a little less than 250 grams per kilometer. And if you multiply the two, well, your footprint just for driving is about 2.9 tons, which is already higher than the objective of 2050. Flying is close, it's a second, and public transport are a close third. Flying has some effects that are usually not accounted in normal carbon accounting, but that you can add because of contrails mainly, and some precursors of radiative forcing in the upper atmosphere. But basically, we can see here that public transport would be the main thing to go to, not because, well, first we use it less, but also mostly per kilometer, it's a much better mode of transportation. We can also think in terms of time. So, okay, maybe some things to remind of before, but I think it's been said before. Yeah, Luxembourg has the highest number of passenger cars per capita in Europe. I would expect to be almost 1 car per person who have a license in Luxembourg, and 30% more driven kilometer than EU average. So we drive a lot on top of having a lot of cars and on top of not being so many per car. So from the latest state study, we are about 1.2 passenger per car. Not a lot of car sharing. So that's reasoning in terms of kilometer, right? But if I reason in terms of time, I can plot the same thing. Okay, sorry about this. And here we have the same quantities on the right. It's just not accounted for in the same way on the x-axis, but the area of the rectangles are the same. We travel about 350 hours per year, which is about 1 hour per day, which I guess some of you travel much more than that. Some of you do less. Of course, this is all an average. But we can see that the picture is a little bit different. You may know that flying, for example, is often shown as a main cause of emissions. It's not so much about the distance travel, it's the fact that you can actually emit a lot by traveling for a short time. This, as I said, is also an average, so it hides another fact, is that a lot of people don't even fly at all. So a minority of, not a minority, but a smaller share of the population is actually responsible for the flying emissions, frequent flyers, for example, while most people have a car. So there's also a lot of things hiding behind these numbers, inequalities, and so I won't enter into that, but a lot of things to talk about if you want to. In the end, what matters is that we have moved to a car world, and that in not even 2 generations. I didn't really have numbers for Luxembourg, so I took numbers for France here, but it's really since the 60s, 70s that that car has entered our world. Our grandparents never had this opportunity to travel a lot, not even by plane anyway, but by car in the first place. So what needs to be clear here is that the same amount of kilometers driven today, even with clean cars or with electromobility or with car sharing, will probably not be as sustainable as we want, as we will see with the next part of the presentation. So we really have a question of volume here that we need to address. So a reduction of our carbon footprint cannot be achieved without even rethinking the role of the automobile in our everyday life. Okay, I will do a last one on flying, and then I will leave to Elorri. I know we're already running late. So flying also, as I said, is highly impactful in terms of carbon emitted per hour flown. It's a very carbon-intensive means of transportation. When we do these calculations, what I didn't mention is that we, of course, take the whole life cycle of the cars, of the flights, so of the planes and their consumption. The first one here is actually all the upstream emissions that you would need to actually deliver refined fuel to a plane. You also have to make a plane, so there's production, and the consumption. If you add them all, you have about 100 grams equivalent per passenger kilometer, which is lower than per car. But there's also another effect that we usually don't account for, and which is not in the Kyoto Protocol for greenhouse gas accounting, which is due to other emissions. I will pass on this one because it's a bit more technical. What's important is to understand that flying, especially in Europe, I think can be criticized since there's a lot of other ways to travel between cities. So here we plotted the carbon emissions of each trips from Luxembourg to main European places, both by plane and by train. And you can see that you would gain mostly, 80% of your emissions just by taking the train instead of flying. It's a bit longer, but it's much, much cleaner to take the train than the plane. There's some variations here because you have different electricity mixes behind the pink bars, but the main issue, the main conclusion is the same. Of course, the time would be different, as I said, mostly, roughly half the time by train. So now we will see the rest of the presentation with Elorri, talking about public transport. How do we do transfer, Elorri? You're sharing?
Yeah, I can just share my screen.
Yeah.
So in fact, I will start with the first Menti question. I saw that some of you already answered. You can see the screen, right?
Yeah. Yes.
So now we'll speak about public transport because we have seen that it's a possible solution, but how far it is a good solution. And we will speak about occupation rate for this analysis. So the question is, how many passengers in a bus? So a bus normally has a capacity of 95, but how many we need to have a lower impact than a car, just a car with one single driver? So do we need at least 3% in the bus, 8, 13, or 18? So it means that we will allocate the impact of the full bus to 3%, 8%, 13, or 18% to have the same impact of just one car. I hope the question is clear. So we need to have a minimum number of persons in the bus to have an impact per person which is lower than a car. Just wait a few seconds. I don't remember how many we are, but maybe some person are still thinking. I hope the question is clear. Okay, so maybe we can conclude with the trend that most of you answer 8%, but yeah, there are some hesitation. Yeah. Okay, so let's go back to the presentation to see the solution. So to have the solution, we will compare the diesel consumption of a car and a bus. So a car, normally it's around 6 liters per 100 kilometers, and the bus is 45 liters. So if we make a ratio, it's more or less 7.5 more of diesel consumption. So it means roughly that we need at least eight passengers in the car. So this question of occupation rate is really important for public transport, and we will investigate a bit more by comparing different transport modes, but with different occupation rates. So here I'm still plotting the carbon intensity in gram of CO2 equivalent per passenger per kilometer. And here we have the different transport modes, so flying, train, bus, car. So here it's an average car in Luxembourg, which is mainly diesel and gasoline, motorcycle, electric bike, bicycle, or walking. So we have different value for each mode. So here we have the minimum and maximum for a flight, so between 100 and 220 grams of CO2 equivalent per passenger kilometer. And here for a car, so if you are alone in your car, it's about 270. But then we have seen that on average in Luxembourg is 1.2% per car. So this is why our average is more around 230 grams that Thomas showed previously. And then if you are 2%, you can divide this number by 2, so it's 138. Then if you are 3 by 3, etc. And the same for the public transport. So we will allocate the impact of the train or the bus by the number of persons in these transport modes. On average, the occupation rate is quite low. In fact, it's a bit less than 20%. And we have this value of 50 or 90 grams of CO2 equivalent on average for a train and the bus, respectively. So with this average value, we are better than, for example, a car with 2%. But if it's only less than 10%, then we can be worse than a car with 2%, especially for the bus. The train is better because it's based on electricity and it's more efficient. So it means that we need to really occupy these public transports. And if they are full, you see that these values that are around 10 grams of CO2 equivalent are similar than, for example, going by bike. So really, if we optimize the use of public transport, we can have a really low carbon footprint. And this is the conclusion of this graph, is that we need to optimize the use of public transport. So if there is a bus or a train going to the same pathway for work, etc., you need to use it and not add an additional car on the same pathway than this public transport. And it's also means that we need to well plan this public transport line, because if they are not used, then they are just impacting more than, for example, a car with 2 persons. So if you don't have public transport, then car sharing can be a good alternative. So especially when you start to be 3 in a car, then you start to have a quite good carbon footprint, let's say. But of course, active mobility, so walking, biking is the best. So you need to have short distance for that. Now we have the option of electric bike that can allow us to make a bit more longer distance, but of course, you need to have the infrastructure to do this. So now we'll speak about the impacts of cars, which is a huge section of our talk, because we have seen that it's really our major source of impact in our mobility patterns. So this is again the life cycle. So like Thomas showed for the plane, we have the different steps of producing the car, producing the fuel, then driving, where you have direct emission, and then the disposal of the car. And we will look at all these greenhouse gas emission sources for 5 types of cars: so diesel, gasoline, full electric, plug-in hybrid, or hydrogen car. So let's start with the infrastructure, so the production of the car. Here, this dark blue bar shows that in the case of electric-based vehicle or hydrogen vehicle, we have a higher impact because we have the battery, we have a heavier vehicle, so of course the impact is higher. Then we have here the production of the fuel, so the diesel or the gasoline. So we don't have an additional bar here yet for the electric. So in the case of the fuel cell, we need a lot of this fuel. And then we have here the impacts of producing the electricity in the case of the electric and the hybrid car. And if we stop here, the electric car could be seen as worse than the diesel and the gasoline, but we didn't yet include the direct emission when we burn this diesel or this gasoline. And here is the major source of impact of a thermal car, is when we burn the diesel and the gasoline, we produce directly CO2 emissions. So each kilometer you drive, you have a huge impact just because you are burning fossil fuel. So with this graph, and this is based on average European data, we can see that from a carbon footprint perspective, the electric vehicle seems the best, then the hybrid, and the fuel cell is a bit in the between. These are the values. So how to decrease the impacts of driving? The graph here shows the carbon intensity again, so gram of CO2 equivalent per kilometer, in function of the weight of the vehicle. And we have different types of vehicles, so each point represents one vehicle type. I put some picture of some points just to have an idea. And they are classified, so the black points are the gasoline car, the gray, the diesel car, the pink hybrid, the red plug-in hybrid, and the yellow, the battery electric vehicles. So again, we see the electric vehicles are always in the bottom of this graph. But besides the type of engine, we see the tendency that the heavier your car, the higher the carbon intensity. So the first strategy to decrease the impact of driving is to go for smaller car. You can really have a huge reduction by choosing a smaller car. And then there are other ways. So if you add accessory, of course, you will increase your fuel consumption. There are ways to do the eco-driving, so keep a constant velocity, for example, have a smooth driving and so on. And I don't see it. Yes, do not avoid the use of air conditioning. Another, just a focus now on plug-in hybrid cars, because if you have such a car, you need to use it as an electric car and minimize the fuel consumption, because a study showed that in fact, and this is the example of a sample in Germany, people were not charging it enough, so they were consuming much more fuel than what is expected. So for example, for private car, it was twice the average amount that was expected, and company cars, it's even 4 times, because maybe people take less attention to charge the vehicle. So this is an important point to decrease your impact if you have a plug-in hybrid car. Now we talked about a lot about carbon footprints, and I wanted to look at other environmental impacts, and let's look first at resources. So we have the same cars, the same life cycle stage, and now we are looking at not the carbon footprint, but the use of fossil resources per kilometer. And here we have a different picture. The difference are much less, are smaller here. And we also can see that hydrogen cars are not very energy efficient. Now, if we look at the use of metal and mineral resources, we have again another conclusion that the electric car are the worst here. This is due to the components, the metals that are included in the manufacturing of the batteries. And now let's look at other types of pollution. So here I'm showing the emission of carbon monoxide, for which gasoline cars are the worst. So this will affect your health, of course. And the nitrogen oxide emission. So maybe you know this NOx, this smog effect that we have in a city. So sometimes you can see warning when it's hot, especially you will have the smog effect. And in that case, the diesel car is the worst, and that's why there are also a policy push to stop the use of diesel cars in the cities. So now I will also again switch to Mentimeters to go through the second question. So the second question is, in how many European countries, so here it's UK included because it was the conclusion of the study before the Brexit. So in how many European countries it is worse to drive an electric car due to the high carbon electricity mix? So of course, the impact, the carbon footprint of an electric car depends on the carbon footprint of producing the electricity. For now, I just show you the average European electricity mix. But now if you look at the single mix in each European countries, in how many European countries do you think it is in fact not eco-friendly to drive an electric car from a carbon footprint perspective? I don't see results. Can you vote, or is it? We cannot vote. Maybe I need to.
We have the first question still on screen.
How do I do this? Maybe. Oops, sorry. Now? Sorry. I need to do present mode. Sorry. So I hope the question is clear. So you need to say in how many countries it is not good to have an electric car compared to a diesel or gasoline car, of course. We are comparing to a thermal car. Okay. So I guess you were already ready to answer because you were waiting. So maybe we can stop here. So many of you think it's between 8 and 11 countries. So a bit less than half of them. And to show you the answer, I will show you the results of this study done, I think, in 2019. So first, this is the impact we have seen of gasoline cars, so around 276 gram of CO2 equivalent per kilometer, the diesel a bit less, and on average in Europe, this is the same results I showed you before. We are about 50% of reduction compared to gasoline car. And now let's see for the other country. We have all the countries, and we have one country for which it is worse. It's Estonia. Okay, if you look at Poland, it's also not so good. But for really the majority of the country, we have a significant decrease of the carbon footprint. And here we are speaking about the carbon footprint. We can see Luxembourg here. And the thing with the electric car is we can also expect that in the future, the electricity will be cleaner, and that will also clean the carbon footprint of electric car. So now let's conclude. So are you ready for a change of your mobility habits? And now I will show you what you can do to reduce your carbon footprint on the mobility level. And I will show how much we can expect to reduce your mobility carbon footprint based on several actions. And this is based on average Luxembourgish data. So your individual habits can be different. This is really based on average Luxembourgish data. So here I just put some action that we investigated together today. Of course, we could add more, but it's just because we spoke about this. So in the small things you could do is to do eco driving. So this is about 6% reduction of your mobility carbon footprint, not the total one. Just we are speaking about the 3.3 tons of carbon footprint we have for mobility. Then we have the fact to not take the flight anymore, the plane, 9%, car sharing, 15%. So of course, as soon as we speak about cars, since we have about almost 3 tons of the carbon footprint, which is driven by the use of the car, of course, we have a higher reduction impact. Then if you don't use the car for commuting, but public transport or active mobility, then it's more than 20%. Also smaller cars, about 25% reduction, and then here the electric cars, about 30%. Small comments for some of these actions. First, for the flights, on average, in Luxembourg, we have about 2,700 kilometers per inhabitant of flying. Just as an example, this is a round trip to Sicily. But of course, if you fly more, then this reduction will be much higher. For example, just if you do one round trip to Los Angeles, you will emit about 2 tons of CO2 equivalent. And this will increase your carbon footprint, so your total carbon footprint, by 15%. So of course, we have seen also with Thomas, as soon as you spend 1 hour more in a plane, you have a huge impact. So this is on the average, but if you are a frequent flyer, the reduction will be much higher. And another comment on the electric car. So this is one of the good options to decrease your carbon footprint, but we have seen that there are potential trade-offs on other indicators, like the use of resources. So there are still some challenges that need to be tackled to have really sustainable electric cars. And again, it will not solve all of the problem. We also need to decrease the traveling distance, as we have seen with Thomas. But we need to solve, for example, the energy transition to have a clean electricity, or also tackle the issue of recycling the metals for the battery production. And with this, I will finish my presentation. Thank you.
Thank you very much, Elorri and Thomas, for this very nice presentation, full of impressive figures. And I've seen actually there is quite a lot of debate going on in the question and answers. So I will try to actually extract from these discussions a few points. So I've seen actually, well, let's start from the very beginning. We had some questions that are related to the sources of energy. And this is actually quite an important point to address, because there is a lot of discussions going on whether electromobility is indeed the solution to solve the problem of greenhouse gas emissions, or is just moving the problem somewhere else. And they have been talking about renewable resources or non-renewable resources, or non-renewable sources for generating this electricity. So do you actually have any statistics on how much energy we actually do consume in mobility that is coming from non-renewable or renewable, and how difficult would it be to actually try and manage the energy consumption in such a way that we only use, or we use the largest amount of renewable energy sources. Anybody has a thought?
Maybe Thomas, it's more your topic, so I prefer to let you.
You want to know how much today we use of renewable energy in mobility?
Yeah.
Yeah, it's quite low, unfortunately, mostly because mobility is still very fossil-based. If you talk about cars, there's only a few % of cars that are electrified today, and most of the electricity they use is not always renewable. I guess the most electrified mobility mode is train and tram. So that will depend on the country where you live, obviously. So if you live in Poland, I think your amount of renewable energy will be close to zero, unfortunately. If you live in Norway or Sweden, then it's going to be much higher. So there's here you're a bit stuck. This is where you see the interaction between policies in energy and mobility, is that both have to work together. You have to push for renewables at the same time as you have to push for electrification. Not all countries go the same speed, unfortunately. So for now, it's relatively small, but the base hope is that it increases to a significant share in the future.
Does this actually depend also on the fact that mobility and especially consumption of energy is much less controllable, is more variable due to the fact that trips are changing along the day, whereas the production has different dynamics? Let's say we can generate more renewable energy only in specific moments in time, and we have difficulties of storing, or at least storing is still not as efficient, right?
This is where smart grids, for example, could play a role. If we're able to drive the demand and to charge electric cars at the moment where the wind blows or the sun shines, then you would optimize that kind of system, obviously, yeah. Vehicle-to-grid patterns where actually the cars themselves will be used to store electricity for the grid are also an interesting topic.
Absolutely, yes. There is actually quite, well, it's actually a point that I was also wanted to raise, and it's coming from Constance. It's actually the expectation of how we will do in the future. So there is a lot of policies, especially from the Ministry of Mobility and Public Works, on developing sustainable mobility solutions. Maybe documents that people already know are the Sustainable Policy or Development Mobilité Durable documents 1.0 and 2.0, where there are quite a few actions that are being put in place in order to foster sustainable mobility. Free public transport is one of the options. Incentives or electromobility is another option. But then, the question here is how is it the expectation for 2050? We will actually be able to reach the targets that are, let's say, foreseen or hoped by the ministries for the future?
Yeah, it's a difficult question. I guess you can see it both ways. Glass half empty is that we start from way too high, and glass half full is that, but at least there's a lot of low-hanging fruits. I guess maybe I can talk 1 minute about the Luxembourg Transition Project that was commissioned by the Ministry of Energy and Urban Planning 2 years ago now. If I can even share one thing for mobility, so just to make my point, is that it's technically possible to get to there. So from about 3 tons of CO2 equivalent per capita from mobility today to about 0.6 by 2050 in the way we calculated it. But it would require a very, very strong change in how we drive or we move. We should actually talk only about moving, not driving, because we would have, for example, to reduce significantly the amount of kilometers driven. We would have to electrify what remains of cars in 2050 and to actually increase the soft mobility shares. Here we relied a lot on biking. So here it's for Luxembourg and the functional area. It's also another thing that in Luxembourg you have to think beyond the borders, as you mentioned in your introduction, that the transfrontalier are actually a big share of these people, of the people emitting in Luxembourg. And by then, probably we could get to sustainable carbon footprints, but it's really important to note that you have to act on all levers at the same time. It's not, you know, it's not like a menu at a restaurant where you will choose only the meat or the vegetarian. You have to use all the options on the menu. So you have to electrify and then reduce consumption. You have to increase soft mobility. You have to change urban planning as well so that it becomes safer to use a bike instead of using a car. It's really all these things to do at the same time. So it's technically possible, but if we do everything, and that's more of a political question than whether it's possible or not.
Absolutely. It's actually one of the things that I always like to teach to my students, the message that there is never one solution that fits all these problems, but there is a big mix of solutions. And then the primary source of the problem is, of course, our own behavior, which also is linked to a few comments that I saw related to being satisfied or dissatisfied about public transport. So people are complaining about, for example, carpooling platform not being that efficient, or public transport, yes, being in Luxembourg more empty buses than overcrowded buses. And if we consider the statistics that Elorri gave on how many passengers at minimum should be in a bus, well, probably in Luxembourg we have many buses that are running empty, and we know very well that this is what we call it a vicious cycle. Less demand, then buses or bus operators are obliged to reduce their costs by reducing the frequencies. If the frequencies are reduced, then people wait longer times, and hence they are less attracted to public transport. So solution to get more public transport is to actually use it more. The more we use it, the better it becomes, and the more and the less vehicles will be there, less congestion, and so on and so forth, which is, of course, a very important thing. But on the other hand, in Luxembourg, as I also read from a few comments, we have the problem with cross borders, and this is also something that is hard to be solved for fiscal reasons, but also because of, let's say, difficult coordination between authorities and operators. In the end, we have to many times use multiple services in order to reach our destination, because some of these services are in another country and we cannot control the efficiency of those services. Do actually your statistics also have the possibility to differentiate between how much a typical cross-border employee generates in terms of CO2 emission and how much is a citizen? We know that distances are very different. Cross-borders on average travel 35 to 40 kilometers one way to get to their job, whereas Luxembourgish residents travel in between 15 and 20 kilometers on average, so nearly double of the distances. And every kilometer travel is more CO2 emissions, as you said, with the planes. So do you actually know what is the impact of cross-borders in relation to citizen in the production of CO2 emissions?
Yes, we have done not exactly that calculation, but similar calculations in the Luxembourg Transition Report, I think the second phase report, where we actually look at the greater area. So consumption patterns in Luxembourg are slightly different from the ones in Belgium, France, and Germany. And then for the cross-borders in these three regions, they also have increase in transportation. I don't have the numbers right here, Andy, but yeah, I would invite you to look at Luxembourg Transition Phase 2. If you Google it, I think it would work. And then we have some, yeah, it's, we were actually in the Luxembourg, University of Luxembourg team, which you probably know more than, as well as I do.
Exactly. I have actually a question related to what Elorri has presented, or the very last conclusions. I was quite curious about this conclusion regarding the impact of long distance flights versus short distance flights. This to me was a little bit counterintuitive, considering that I thought that the largest amount of CO2 emitted was especially on the taking off of the planes, because once the plane is getting to a, let's say, cruise speed, then
consume less. But yeah, Thomas didn't spend much time, but per kilometer, the kerosene consumption and therefore the carbon footprint of a long distance flight is smaller than a short distance flight, but per kilometer. But you do much more kilometer, so the difference I don't know, it's about maybe 15%.
I can share it.
20%. Well, I don't remember exactly. The short distance flight is around 4 liters per 100, and the other 3. So maybe 20% less. Yes, exactly. Yeah. Yeah, a bit less than 20%. So per kilometer, indeed, but you do much more kilometer with a long distance flight. So this 20% decrease, you compensate it very easily, because you do five times the distance or more, etc., with a long distance flight. So and the graph with the hour spent, the first maybe Thomas with the per hour, I think this is a very nice graph to show, okay, on average a Luxembourgish person only spend maybe 4 hours, this is something like this, in a plane.
On average, yeah.
On average. But some people do not take the plane at all, and some people spend 10 hours in a plane, or 20 hours, or even more, I don't know. So it means that each additional hour, you will have a huge impact. So if you think about more than 100 kilogram CO2 equivalent per hour, so yes, if you have spent 10 hours, then it's about so yes, 10 hours is 1 ton, yes, more or less. Well, it could be even more. But yeah, so if you think like this, then you know that each flight you will do, then you will increase, and the longer is your trip, the more impacting it will be, because even if per kilometer you have a decrease, so for some, yeah, if you compare, I don't know, Luxembourg, Barcelona to Luxembourg, Morocco, maybe, I don't know, there is a source of Spain in a comparable distance, maybe there is a similarity, but then normally as soon as you go above 2,000 kilometers, you have a huge impact.
Absolutely. What needs to be also considered here is the frequency of flights that we have with that distance, and the alternative that you may propose in order to avoid flying. And in that sense, of course, long distance flights, like the example to get to Los Angeles, well, there is essentially no valid alternative to get to Los Angeles within a reasonable amount of time, whereas Amsterdam, Brussels, Paris, you can reach them quite easily with the train. And then in that sense, maybe one lost opportunity that we have as a European countries is to create a network of high-speed rail that would be maybe better connected to airports or hubs, in such a way that it becomes much easier and more convenient for you to take a train from Luxembourg to Amsterdam directly off board in Schiphol Airport, and then take your plane. And this should be as fast as taking a city hopper to reach the same destination, or to reach the hub. Right now, if you want to go to Amsterdam by train, well, you better drive to Amsterdam as an alternative to taking a city hopper, which is, of course, not the right solution as well. One more topic, which also I find it particularly relevant here, is that we have been always talking about the impact of moving, but a lot of people here are pointing at also the impact and the positive effects of not moving. So we have been learning a lot during this period of the COVID crisis, that we can do a lot of things without necessarily traveling. And sometimes it's even more convenient for doing activities. We have been learning that we can avoid traveling to go to some meetings, even go to shopping. We found that there are logistic services that can do shopping for us. So how much this could be for the future, a very effective solution for reducing the total carbon footprint. We have been talking about remote working, and there are many countries which make it even obligatory to work for at least 1 day a week, either at home or in a remote location, to then reduce the kilometers traveled. But we also have other policies, like in the Netherlands or UK, which is called From 5 to 4, where they oblige people at least 1 day a week to take one alternative mode of transport than the car. So, which I find it quite interesting, because, I mean, we can be busy for 1 or 2 days a week and make it impossible to do it without the car, because maybe you have just activities that are hardly be reached without the car. But traveling every day by car, commuting every day by car, is just an excuse of a bad habit, because we can arrange our schedules in such a way that at least 1 day a week we can travel with public transport, or we can walk, right? So how much do you think reducing the number of trips might actually create benefits in terms of reduced carbon footprint?
Elorri?
Yeah, the question, so you spoke about several things, but maybe if I start with the question of teleworking, in fact, it's not an easy question, because there are hidden side effects to teleworking. So of course you would be tempted to just take the credits of not taking the car, for example, for the days that you telework. But in fact, it's a bit more complex than this. People have seen, for example, a survey in France, that people who were teleworking partly were doing more kilometers per week than people who were not teleworking, because they tend to live further away from the work than the people who should do the travel every day. So there is this potential rebound effect, and there are others, but the fact that if you do teleworking, you tend to maybe live in a far away house, because you want to have something which is maybe cheaper, so near the work it's more expensive, or you have more space, you want something at the countryside, and you will have a bigger house with a specific space for your office. So it's very difficult to assess, and there are studies that assess the impacts of teleworking, but usually they really focus on the travel itself, and sometimes the energy consumption at home versus at work, but not all these side effects that are more in the future, in the long term. So yeah, I cannot conclude. It seems a good solution, and it could really be powerful, but we need to mitigate these potential negative effects of teleworking. So I'm in favor, but we need to be careful how we implement, and that people do not produce other impacts in another way.
Yeah. Absolutely. I can see also there is, again, a lot of debate going on in the chat, also related to the fact that not every time is possible to adopt some policies. People have constraints, activities, children to go to school. And it's obvious that this is a solution that would require maybe to have more flexible planning and management of our transportation systems in order to address all these problems. And this, as I always say, is a problem that you cannot solve it and then forget about it, because they will reoccur in the future, because transportation and mobility is a temperature of welfare. The more people do activities, the more people have advantages of doing some activities, the more we are moving. And we know that the number of trips are increasing in almost a linear way with respect to the GDP of countries. And of course, if we want to be richer and more, let's say, satisfied of our life, we necessarily also have to move. Having said that, Laurent, I'm looking at the time, and I'd like to actually ask you whether I should stop with the question and answer. Just let me know.
Up to you. I think it's very interesting. There are a lot of very interesting discussions in the chat. Maybe we should release our speakers because they have other things to do. But what I will do, I will collect all the questions that we have and see if there are some that needs to be answered, and I will certainly put them in the intranet pages with the presentation, so that we do not forget also important answers that needs to be shared with the participants. So I propose that we close, if this is all right with you, and I would like again to thank Elorri, Thomas, and Francesco for this very interesting webinar. I hope that you enjoyed the presentation, the Q&A session. So the recording of the talk will be made available very quickly on the intranet page. I would like also to invite you for the 4th Sustainability Lunch Talks already, that is scheduled on Wednesday, the 24th of October. And we will address at that time the biggest issue of our time, climate change. So this will be, again, a bit, of course, redundant with what we talked about before, so mobility, but also food. But we will try to have a scientific understanding of climate change, and I'm sure that this is on the agenda of everybody. So I wish you a very good afternoon, and I'm closing the talk by thanking again Dr. Elorri Igos, Dr. Thomas Gibon, and Professor Francesco Vitti for their excellent contributions. And
Thank you, Laurent.
thank you.
Thank
Goodbye
you.
to all.
Thank you,
Bye-bye.
everyone.
Hi, everyone.
Bye-bye.